KWANSO is a transport telematic mobile application developed to combat the undeniably terrible traffic congestion on the streets of Accra. The application allows a user to request for the least congested traffic route from a departure point to a destination point. For each user request, the application connects to a background Oracle database and an enterprise Java service, which dynamically generates a submap of all possible routes for the selected point of departure to the selected point of destination. The application then runs the least congested routing algorithm over the dynamically generated routes and computes the least congested route for the selected journey. The shortest path or the least congested route is returned to the mobile application in two forms. 1. A list of junctions or nodes to move through, and 2. A directional map indicating the path to traverse in order to have the least congested traffic. Let's go ahead and look at the demo. On launch of the application loads all the nodes that are applicable. A user will then key in his point of departure to the point of destination. So this is an example for a user traveling from Spanner and wants to arrive at Ridge Road. The user continues by clicking the Get Best Route button, and the application loads the least congested route as a list showing the junctions to go through. So for this selected journey, the user will have to go through from Spanner Junction to Shangri-La, from Shangri-La to Century Junction, from Century Junction to Silk Junction, on and on and on and on, all the way down till he arrives at his destination, that is from Aliza Junction to Ridge Roundabout. The user could view this also on a map. So there is a map indicating the route that the user should traverse in order to move from Spanner Junction to Ridge Road. Unlike other applications, this map is not drawn using the Google Map or Google Directions. It employs the Google Map but not the directions, because the least congested path cannot be given by the Google API. We could view also the route on other map views, like the satellite view. So this is a view indicating the route that the user should traverse for the selected journey. We could also view it in the town view, showing a layout of the town and the route that we should traverse. All these routes are drawn by the application and not using the Google Directions. A user who has also traversed some part of the road could submit the distance or the time that he used to traverse that portion of the road. So if a user should submit that he traveled from Polo Court to Airport Roundabout and report that he spent this amount of time in traversing that road, that is 0 hours, and then let's say 9 minutes. On submission of this, it goes to the API, it goes through the API to the Oracle database, and it's used to update the data in the database. Multiple users submit their request, and for the same route, that is from Spanner to Ridge Road, because users have submitted requests indicating that the routes are shorter or the congestions are lower at some other sections, we could see that the route has changed. This time, the user is going to move from Spanner to Shangri-La, Shangri-La to Polo Court, Polo Court to Airport Bypass Roundabout, Airport Bypass to Airport First Junction, Airport Bypass to Airport Junction, and so on and so forth to the destination, that is Aliza to Ridge Roundabout. Let's view it on a map. So here we have a similar map for the same route, but this time due to user submissions of least congested route, the application gets updated and gives a user the least congested route, which is a different direction to the destination. The aim of this application is to reduce the burden or to reduce the traffic congestion on our roads, as the vehicles will have a foreknowledge of the traffic on the individual road before they leave their destination point. So we could now have our application on our mobile phones and then we would know the congestion on our roads before we leave our homes. In this way, all vehicles will be evenly distributed on the roads. We plan to involve other sensors such that we could have better route. So this, for example, a user who is traveling from Spanner Junction to, let's say, the Spanish Embassy, he'll also get a list of nodes that he should traverse, and he could view it on a map. So he gets to know the least congested route from Spanner Junction to the Spanish Embassy. The application is aiming at employing algorithms that are used in data networks to ease the load on our road networks. In this way, all vehicles will be evenly distributed on the road networks. We intend to combat the traffic congestion by going further to mount road sensors that will directly feed traffic congestion on our roads to our Oracle database, from which the application will pull its source of traffic congestion. By doing so, we mean we are going to have devices like the Raspberry Pi being mounted on road networks, and we would measure the traffic congestion which we would use to feed the application. The application is currently deployed on a local network and has been tested and is working perfectly fine. We are waiting to gather more information on the road networks so that we will roll out onto the internet and the Google Play Store. The application is currently not rolled out as we await funding to purchase sensors, and also as we populate our database with nodes and with traffic data. We will allow for integrations to applications like the Snow Code and other applications to make use of this. Thank you.